So, good evening, everyone. My name is Shig Okaya, Deputy Director General of National Institute of Science and Technology Policy, Ministry of Education, Culture, Sports, Science, and Technology. Thank you for allowing me an opportunity to share my previous experience in the management of development of the post-K computer, Fugaku. A project using 110 billion yen of taxpayers' money is naturally very controversial and caught attention of the public. It entailed many ups and downs technologically, but more so in discourse with various stakeholders. I hope this story of management will give you some insights in pursuing large national projects like HPC development. But first, let me introduce myself. I served 5 years in RIKEN in charge of post-K computer development and RIKEN's AI Center management from 2015 to 2020. Being a government official myself, I participated in management of research institutions in Japan and abroad, including ITER, International Thermonuclear Experimental Reactor in France, and top national research institutions such as AIST, the Institution for Industrial Science, and RIKEN in Japan. And I also assumed many positions in ministries of Japanese government, MEXT, my ministry, and Ministry of Trade and Industry, METI, and Ministry of Environment. And last but not the least, Science and Nuclear Attaché at the Japanese Embassy in the USA, where I had made lots of ties with Department of Energy and other federal agencies. By training, I have Master of Science in Nuclear Engineering from Kyoto University, and I have an MBA from Stanford University. Before K, NWT of NAL from 1993 to 1995, CP PAX of Tsukuba University, 1996-97, Earth Simulator JAMSTEC, 2002 to 2004, won #1 in top 500. So Japan had fastest computer built roughly every 70 years, but most of the predecessors were designed for a single purpose. When K computer development was just about to be launched, there was a change of power in Japan. A publicly open screening process took place where the incoming Democratic Party scrutinized the outgoing LDP's previous decisions. Why can't it be #2? Became such a controversial cliche aired on TV. This is a picture of a famous Democrat politician in this public hearing screening process. Perhaps this was one of the highest public awareness moments that caught attention of many Japanese at that time. Because of this political visibility, #1 in speed became paramount to this machine. And K indeed became #1 in top 500 in June 2011. Meanwhile, K used Spark architecture, which was not globally popular. Some of the industry members backbited on K, saying academic ivory tower, criticizing its difficult usage. In December 2013, the Cabinet Office Committee on Science and Technology Policy has made a prior evaluation on development of post-K computer. The committee identified HPC as a key technology tool for nations' competitiveness. They recommended Codesign. Learning from K computer's experience, we needed to have application fit design of the HPC. As you focus on specific application and design HPC along with it, you can bypass adjustment of application saving 2 years maximum for actual application output. But at this juncture, this co-design was still conceptual, with no target application identified. They also set other targets. Maximum 100 times more than K in application speed and 2 to 3 times more than K in energy consumption. Preliminary studies suggested use of accelerators. But after this pre-evaluation, the accelerator vendor dropped out from the development. Therefore, the design needed to be changed. This is the graphics of co-design concept of Post-K, where science of computation and science by computation collaborate together to have smoother and faster output of the simulation. In January 2015, CSTI, which used to be called CSTP, reevaluated the Post-K development program in the wake of the droppage of the accelerator vendor. It named it as Flagship Project 2020. 9 target applications were identified. Applications such as earthquake disaster simulation, climate change, material science, combustion and fluid dynamics, etc. The scope of the project was to have maximum 100 times more than K in one of the target applications. They also set limit to total government spending, including application development, into 110 billion yen. They said risk management is necessary, as CPU will be sourced outside of Japan. They also said to gain understanding from the public, clear articulation of the outcome is necessary. The report is also pointing the necessity of stronger management system among mixed, RIKEN, and the vendor, because appropriate decision for plan alteration may be required to match the social and technological change in and outside of Japan. Now, this is an overview of a stakeholder and the management of the project. Here we have politicians. In green, we have government offices, mixed, and the cabinet office. The RIKEN here on the left side, and application scientists on the right side, and the vendors. Vendor and the subcontractors. RIKEN, president and its headquarters, is located near Tokyo, Wako, and was responsible for the entire management. But the engineers and scientists belong to the subentity RCCS, which was located in Kobe. I was nominated in both Deputy Executive Director and Deputy Director of RCCS. And also, I was on loan from MEX, so I went go-between between the government and the RIKEN. Because of co-design, fund went to application scientists directly from MEXT to avoid RIKEN's over-dominance to the application scientists. But fluid technical meeting took place with the vendor involved. In November that year, administrative review on the current LDP regime picked up Flagship 2020 as an issue. This entailed open public hearing chaired by Minister of Administrative Reform, Mr. Kono, a politician, of course, and external experts from various fields, including now president of Keio University, Professor Ito. This is a picture of the open public hearing. The minister concluded with remarks including the following too. About 110 billion yen taxpayers' investment is expected, but the expected return, both in terms of science and in terms of economy and society, need to be well explained to the public. Number two, because limited company will be undertaking the project, cost reduction and project management should be double-checked by external experts and with global comparison in mind. Notice this, with global comparison in mind. And comments from the experts included the following. Unlike case of K-computer, Japan cannot fabricate chips by itself. How do you frame our national merit? It is good that you have target application and its goals, but you need to dig deeper what that really means scientifically. One might easily assume that only limited scientists enjoy the luxury of the machine. The real scientific benefit should be shown as an outcome of the output. The amount of investment and target of the outcome are all considered in Japan. We do not know whether they are appropriate internationally. More deeper analysis and comparison should be done internationally. In January 2016, MEX has approved the basic design of Post-K. They specified 4 characteristics of the machine: speed, energy efficiency, ease of use, impact of outcome. First time to be mentioned that Post-K should aim at larger and diversified users, and ease of use to be one of the key characteristics Post-K should be designed into. Right after this, Riken and Fujitsu signed detailed design contract. In March, basic design and MEX evaluation is confirmed by CSDI, the Cabinet Office. They stated following 3 points. Planning of ripple effect study, adoption of ease of use as characteristics are highly appreciated. Stronger emphasis is needed for energy efficiency. An international comparison of the 4 characteristics is necessary. In June that year, use of ARM architecture was announced by the vendor. ARM was favorable from following perspective. A, of its high energy efficiency. B, wider usage in software development community. C, purchased by Japanese company SoftBank, which occurred a few months later. In August that year, because Moore's law has paced down, the chip fabricator had to delay the delivery, but promised to upgrade the pitch size of the CPUs. MEX has acknowledged the schedule delay from 12 months to 24 months and confirmed the change of technology of CPUs, chip size, and memory change. They requested upgrade modification to enhance usability. The delay cost was burdened by the vendor and no taxpayers' money was incurred. The delay cost might have been mainly labor, which could have been their sunk cost. In December, IDC, now Hyperion, reported a study of ripple effect of Post-K to the MEX subcommittee. And this was mentioned and publicized in K-Computer Midterm Review. This is a slide that Earl Joseph of Hyperion now has used in the subcommittee. In 2017, January, Riken and CEA France signed a collaboration agreement. This is a picture of the signing ceremony of the president of Riken and chairman of the CEA. The main scope of this agreement was on collaboration on ARM-based software stack. As EU was looking into EU HPC based on the same ARM architecture, RIKEN started to build close alliance with CEA to build ARM-based software stack. With already existing RIKEN DOE collaboration, this is a strategic government-endorsed move to establish geopolitical platform that allows stable development of ARM-based ecosystem among three economies. In October that year, cost and performance evaluation by MEX was done. They acknowledged FP16 and memory change. They appreciated international third-party consultants' report. One, comparison of performance of HPCs at the time of post-K delivery. Two, evaluation of post-K usability. They also welcomed adoption of Linux distribution, collaboration on open source community, and the pursuit to establish ARM ecosystem. In September 2018, midterm evaluation report was done by MEXT. The first chip sound evaluation reported by RIKEN confirmed steady progress to the target. The report stated that FP16 deployed will meet wider user demand on deep learning. They also said high-end ARM CPU is expected to be utilized worldwide. In November, midterm evaluation was finally done by CSTI, the Cabinet Office, which gave final green light for fabrication of the post-K. In 2019, March, fabrication started by the agreement between RIKEN and the Fujitsu, then the vendor. In May, post-K is named Fugaku. Fugaku is another name for Mount Fuji. This is the Mount Fuji, right? The name implies of its high performance, which represents the height of Mount Fuji, the highest mountain in Japan, and also the wide usage. Notice this is a volcano with a wide tails. And this picture here is the president of RIKEN at the time of naming ceremony, having Fugaku's name in Chinese character. In 2020, Fugaku was installed in Kobe in May. In June and November, Fugaku won 4 top awards in top 500 HPL, AI, HPCZ, and the Graph 500. See those 4 awards. In 2021, Fugaku started service to the public use. Total taxpayers' money spent was 107.8 billion yen, which is below the budget limit the CSTI has imposed. The service started within fiscal year 2020, which is also within time limit. So what was effective in convincing Japan? Number one, changes from speed paramount to 4 characteristics. By adding ease of use, energy efficiency, we were able to dodge the negative criticism of K computer. This pushed the introduction of ARM architecture. Number two, introduce non-Japanese expert consultant to give non-Japanese perspective. Japanese stakeholders and experts always had some reservation of RIKEN's experts' view. Outside evaluation, international comparison by the famous international consultant gave balanced view on the economic and scientific ripple effects, performance, and usability of post-K machine. Expanded potential user community. ARM CPU and FP16 signaled to wider range of potential industry users. It has caught attention of many non-former K users in the industry, building up wider support and expectation. For example, SoftBank and its subsidiary software companies. Number 4, international coordination and global market horizon. Collaboration with Europe and US made wider software cohesion and gave rise to the potential global standing on Postk usability. This was not so in K computer. Number 5, contingency management. We established contingent management strategy with MEXT, RIKEN, and Fujitsu, the vendor, that had quick response to irregularities. This included top-level hotline. And last but not least, the real output. The actual data of chip was convincingly good. So I was asked by the organizers to address some of the issues I foresee for the HPC. Here are the issues. Number 1, simulation needs to provide outcome to the society. Fugaku showed visually COVID-19 virus spread in many situations. This was timely, and the public recognized the usefulness of HPC. But extreme weather is causing landslides and other disasters. Fugaku simulation permits solutions and predictions, and public is waiting for its sound applications. Number 2, technology to enhance energy efficiency is needed. As chips' nanodensity becomes smaller, energy density gets higher, which cause dark silicon issues and other problems. Nanotechnologies such as silicon photonics need to be adopted. Number 3, chip fabrication demand increased more to edge computing. Internet of Things, or Society 5.0 in Japan, requires large data transfer. To decrease that burden, edge computing is highly needed. Edge computing is also critical for robotics, current and prospective outcome of AI usage. Thus, more industrial resource will be geared to such chips and may have influence to the HPC chips. HPC chips fabrication resources. Number 4, industry will have more international alliance, possibly some of the groupings. Just like other heavy industries, the ones that I experienced in before, like nuclear, rockets, and all kinds of heavy industries. HPC vendors business become more consolidated into few global alliance or few global groups. Just like other heavy industries, business leaders need to be aware of governmental regulation and work closely with allied nations. So, thanks for listening, and hope this will be something of value to you and help you in your career development and your planning of the HPCs. Thank you very much.